Okay, so now that we've reviewed operations on the integers, now we're going to do operations on fractions. Okay, so hopefully we all know what fractions are. Operations being multiply, divide, add, and subtract. Okay, with addition and subtraction, usually you start with addition and subtraction. Okay, but with fractions, we're going to start with multiplication and division because it's a little easier. Okay, it's easier to multiply and divide fractions than it is to add and subtract. All right. So we're going to start with that. We're going to multiply two fractions. So let's start with an easy example. Okay, so 2/3 times 1/3. Okay, how do I multiply fractions? Just multiply the two numerators together, multiply the two denominators. So 2 times 1 is 2, 3 times 3 is 9, and that's it. Okay, pretty easy. In that case, they were both positive, so I knew that I multiplied two positives, then I end up with a positive. Okay, so our signed number rules from the last video, they still are in effect here. That is, if I multiply a negative by a positive, okay, note the different notation there. My first example had a times. In this case, I just have two parentheses, two numbers right next to each other. It's assumed that you're multiplying. 2/3 times negative 2/3. So the rule for multiplying fractions is the same. Multiply the two tops, the two bottoms, and remember, the rules from before are still in effect. 3 times 3 is 9. 2 times 2 is 4. And I multiplied a positive by a negative. So I still end up with a negative. Okay, positive times a negative is always a negative. Just a quick note on fractions, negative 4 over 9 is the same thing as negative 4/9, okay? Which is the same thing as 4 over negative 9, okay? This, you can interpret this as a negative divided by a positive, which is in fact a negative number, okay? But either way, any of these are the same thing. Most of the time we like to write it as a negative number. So in other words, put the negative sign right in front of the fraction bar. That's how typically you'll see it written in your textbook, okay? Let's do some more examples. How about 4/5 times 25 over 16? Negative 4/5 times negative 25 over 16. Okay, so again, the rules are the same. In this case, I can multiply the two numerators and two denominators and get a result. It's going to give me a large number. Technically, to be correct, I could always look to reduce fractions, which is what I should be doing. Always look to reduce a fraction when you get an answer. That one doesn't reduce, that one doesn't reduce, okay? But before I do that, there's some reduction I can do before I multiply. That is, I can find a number that goes into 4 and 16. And then in this case, in this example, I can find a number that goes into 5 and 25. So I can reduce these fractions to make the multiplication problem a little bit easier. Okay, that is, I know that 4 and 16 both have a common factor of 4. So I divide them both by 4. 4 goes into 16 4 times. 4 goes into negative 4 negative 1 time. Okay? What about 5 negative 25? Notice I'm going to sign that negative with the numerator. Okay, like we said, I can put it anywhere I want. Typically you'll see it like this, but it might help to put it up top, and that's what I'll do. That is, I'm going to assign the negative to the 25. So 5 and negative 25, 5 goes into both of those. 5 goes into 5 once. 5 goes into negative 25, negative 5 times. Okay? So now I have a much easier problem to deal with. I got negative 1 times negative 5 over 4. Okay, but I follow the rules. Multiply the two numerators. Negative 1 times negative 5 is 5. 1 times 4 is 4. Okay? If I missed that, I would have multiplied these together. I would have got larger numbers here. Right? I would have got 4 times 25 is 100. 5 times 16 is 80. I get 100 over 80, and I reduce it to 5 over 4. But if I can do this first, it makes it a lot easier. Okay? Another example. How about 5 times 4/15? Okay, another notation here. This little dot means time. So 5, it could look like that. And that's the same thing, okay? Different notations for multiplication. I want to show you all of them. So 5 times 4/15, that one looks a little different than my previous examples because that's not a fraction, right? And we'll come up with these. This is an integer from the last video, right? So I got an integer times a fraction. So what can I do? I can always make an integer a fraction. 5 and 5/1 are the same thing, okay? So once I do that, now it falls in line. I can do the exact same process I did with the previous examples. Multiply. Numerator, numerator, denominator, denominator, and get my answer. Okay, but remember, before you do that, look for cancellation. Common factor 5. 5 goes into 5 once. 5 goes into 15 3 times. Notice you have to divide both of these by the same number, right? By the same number. And that gives me 4/3. Remember your signs. In the first example, 2 positives gave me a positive. Second example, a positive times a negative gave me a negative, right? Second example, a negative times a negative gave me a positive, right? Just like from the rules before. Example 4, 2 positives gives me a positive when you're multiplying, all right? Let's see. Let's do 2 more examples. Example 5, 4/65, 13/100. Okay, again, you can see this in your book. It might be given like that, negative 13/100, or the negative will be up top. What I like to do is just assign that to the top, right? Remember, we talked about that. Those are the same thing. And then I can just think about that as a negative 13/100 when I go to do my multiplication, when I go to do my reduction, okay? So look here, and I can see that there is a number that goes into those two. 4 goes into both of those. And there is a number that goes into these two, maybe not quite as obvious, but 13 does go into 65. So divide them both by 13, and 13 goes into 65 5 times. Okay? So again, with this cross simplification, I'm simplifying here, I get 2 easier fractions to deal with, 2 reduced fractions to deal with. 1 times -1, -1, 5 times 25, 1/25. And it's okay for me to leave your answer like that if you want, or you can write it as a negative fraction, -1, 1/25, okay? All right, so let's see. 4/16 times 3/4, one more. Okay, in this case, there's a couple things I can do. You'll notice here, this is a reducible fraction, right? The fraction itself, I could do the 4 and the 4 and reduce that way. I'm going to get the same answer as if I can reduce this 4/16. Remember, I can also reduce a fraction like just a typical fraction, 4/16 reduces on its own, right? That's 1/4. 4 goes into 4 once, 4 goes into 16 4 times. Okay, and now there's no other simplification to do, so I can multiply across and get my solution, okay?